Okay, so like I said a bit earlier, and for the guys that haven't joined early, we're aiming to be finished by the 15 with all of these prep, so that we can nearly give you guys a week and a half of just going through work. If there's questions after the 15, post it on WhatsApp. I'll put it in a slide pack, and we can work through it. But the aim is to get through all of the prep by the 15. So you will see that it might even be that the next two sessions becomes 2-hour sessions, but that is my aim, that we finish by the 15 for you. But I know there's other exams and stuff as well. So and then that last week and a half, it's more check-ins and as you work through, and I'll also check for previous exams. I know I've got lots of previous paper exams, so I'll definitely share that with you guys as well. Okay, so let's go into where we left off last week. And this I should have also moved up earlier, but let's look at, and this is purely a definition question on study unit 3. So basically that you need to, let's get my, so they ask you which of the following statements is correct with regards to a negative skewed distribution. Okay, so can anybody remember how does a negative skew distribution look like? So normally let me just get it right. It looks something like that. So your normal distribution, let's say that is normal distribution, then your positive has is also, what do they say, tailed to the right, and then your negative, and it's also tailed to the left. And what that means is there's a long tail here to the left. Same with the other one, there's a long tail to the right. Okay, so let's just look at the options. Obviously, what I've done behind this block, there is some nice clues for you that you don't need to remember this. But if I look at these, the first thing I remember from a normal distribution, that mean, median, and mode is exactly the same. So option 3 is not, because that basically tells me that I'm looking at the normal bell-shaped distribution, which it's not. Okay, so let's see what each of these say. The mean is less, so the mean is less than the median, and the median is less than the mode. Okay, so if we look at now only this one, because this is the negative, the mean is the one that is the average. So the average will probably, because there's that long tail there, will be interesting where the average sits. Gosh, let's just see if I can undo that. Cool. The mean and the mode, or the median and the mode, will sit somewhere here, because remember that is still your median. So your average will sit somewhere here, and your mode, it's difficult in this one to say where your mode is, but your mode is probably up at the top. But your mean is definitely smaller than your median. And the reason why is, so let's just bring those other two. There's your median. Your median is always in that middle. When we look at that, your median is always in the middle. So this first one is actually the one that is correct. But let me take this away. I know it is small, but let me just see if I can zoom into this. So here's a nice way of looking at it. So your bell shape, all of them is always in the middle. Mean, median, and mode, always the same. Negatively skewed, and that is basically what we did now. Your mean is more to that side. Your median is always where that curve basically makes the turn, and here they say the mode is bigger than the median. So when we've got the left or positive, it's just, or sorry, right or positive, it's just the opposite. So you can see your median is always in the middle. I think that's the important thing. Your median is always in the middle. So let's just look at this question again. And if there was, the mean is less, so median is in the middle. Mean is greater than the median, and the median is greater. So there they also said it that way. The mean is greater than the mode, which in turn, so that already is not going to work, because the median doesn't matter if it's negatively skewed or positively skewed, median is always in the middle. The mean is less than the mode, which in turn is less than the median. So just by elimination of what we know, those three was in any case incorrect. Okay, but for this one, please, here's a nice, and it's very small now, but when I share it, you can definitely look at it. I think what I'll do after today's session, I'll share the whole pack. Then you have it, and then as we go through it in the next 2.5 weeks, at least you have it as background, and every time that I add my notes, I'll just share it again. And I think that is probably the best, when you can also have a look at it beforehand and even ask questions as we prep for this. So and I just want to make this a bit bigger again. Okay. But this is, yes, Lynn.
Sorry, John, just a quick one. In terms of reading the graph, we read the values increasing from left to right, and not the actual the graph itself. So if you look at
Yes.
okay, cool. So as it goes to the right,
Yes.
the value increases. Okay, thanks.
So just look at it as what we did in study unit 6 or 7 nearly, when it was even a Z value, that it goes bigger to this side and it goes smaller to that side. So it's the same year where okay, your median is always in the middle. So if that was on the normal axis, say that would have been 145. And then your axis would go up and your axis would go down. So it, so it is nearly, you can look at it nearly from this way as well. So, and I know this is now going to look very weird, but look at that. You could have drawn a nice,
Okay.
a nice normal distribution around that nearly.
Okay.
Okay, so that is, if you look at even this, so if you look at this one, that is nicely, there you have it, there you have it, there you have it, and there you have um
On the other side of the left-hand side of the box, right? Because left to right, I think, is increasing. Huh? Is it? Okay,
just
you're
look
back.
at this
Yeah,
one
yeah.
where
You're back, huh?
where so that was like, there's a long, oh sorry, and there's that, so there's your long tail, there's your, so here your median, you can now actually see with that one, it's something like this, which will be your negative tail. So a lot of these actually is you can represent into one of those graphs a normal distribution or not. So that for me is just, and sometimes when we did it as study units, you don't always see how all the things comes together, and how it's related nearly, but it's nearly everything moves into the other work. So thanks for that question, Lynn.
Okay, thanks.
Okay, so now we get a bit into probabilities. So let's look at this, and this is where we, and you will see there's, I think, 2 or 3 like this, where some of it is merely that we need to work out the probability. Some will ask us to work out expected values. Some will ask us to work out something different. So for this instance, let W be the event that the distance from home to school is less than 3 kilometers. So we can just basically, if you want to write it out, is less than 3 kilometers. So we'll see now what the probability we will need to work out. Determine the probability of event W occurring and choose the answer from the list of options below. Okay, so if you look at it, let's first see how many points are there. 1, 2, what did I say? No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So how many of these are less than 3 kilometers? There's only those 3. So only those 3 is less than 3 kilometers. So this one was an easy one. What's the probability? 3 out of 10, and that is 0.3. They could have asked us more than 6, then it would have been 1, 2, 3, 4 out of 10. So just, I think this is one of the nicer ones or the easier ones. That is straightforward. But what I think it's important here is that you need to that less than and so if there was a 0.3, and I think that again is what I just want to show. I hope I'll have a table later on with all of those. But if there was a 0.3, they still say less than 3. So then we will not include the 3. If it was less than and equal to 3, then we would have included the 3. So just be very careful again with the wording. Here it's less than 3, so anything less than 3, there's only 3 points. What they could have done as well, and so again, just a tip, it might happen, is that you look at the data, there's maybe 3 points, and somewhere here, there's a 2.9. Just be careful when you look at the data. So just look at the whole data set and see if there's not something in there that they want to catch you out, because they didn't say this is ordered or anything. So it might even be that they want to catch you out and there's a number in here that is also less than 3. So just in that sense, in the exam, again, time-wise, you don't have a lot of time. So you just quickly, as I did now at the beginning, you quickly say, okay, there's a 3 that's less than, and 3, we got it, we go on. Just be careful in the exam, please. Yes, Lynn.
Sorry, John, I'll be quick. How come we didn't use the actual values of the first 3 points? And we just took,
Okay, so
yeah.
okay, so they haven't asked us here what's the average of the 3 students or what's the average of less than 3 kilometers or what's the mean or what's they ask us here what's the probability, so how many people stays less than 3 kilometers from school. Okay, so that's why it's they haven't asked us how far they stay from school. They just ask us how many people stay less than 3 kilometers from school. Okay, so that is also where you guys need to pick up the differences between where you need to actually calculate the mean, median, and those kind of things versus the probability of things. And in the exam, it will be exactly the same. You will still work on a mean, median, and mode question, and then the next question will be around probabilities. So just another thing that you need to pick up on.
Cool.
Okay,
Yeah.
cool. Okay, so let's see if we can make this also a bit bigger. Okay, so this now is purely probability. They give you the whole table. They don't ask weird things. They tell you there's 800. So we will probably need to calculate some totals again. But before we even go that route, let's just see what we need to do. Okay, there's a table. Calculate the probability that a random chosen learner travels between 3 and 6 kilometers from school. Okay, so that's, they tell us between 3 and 6 kilometers from school. So that is going to be our focus. Given that they are in high school. Okay. Given that they are in high school. Let's rather do that. Okay, so given that they are in high school. Okay, so how would we do this? I just want to have some space for me to write. Okay, so this, and it is part of the set of formulas that I will send to you as well. But basically what we have here, and I'm going to write it just in first in normal, and then we can just fit it in. So what's the probability of A, that 3 to 5, given B? So what's the probability of between 3 and 6? So let's make that A, given that the person is in high school. Let's make that B. Then we don't need to, and that is the probability of A and B. And I'll just now say how I remember this one. So how I remember this one is we sit with probability A, B. So at the top, probability A and B divided by the probability of the second one. So what we have here is we can do it on two different ways. So let's first we need to get this total. That's 0. I think that's 280. So we can do it on two ways. We can work out what's the probability of A and B. So that is 112. So we could just say 112, or the other way is to say 112 divided by 800, so that we can get the probability of it. And then we need to say what's the probability of B, that is high school. Okay, so that we also now need to add up. So that is 112, that's 160. It feels like 320. So we could have said, okay, well, we need to divide that by 800 because we need to get the probability. Or we could have used it just as that, because in the end, these two 800s, when we're using math, will in any case be cancelled out. So probability that the person is between 3 and 6 kilometers, given that he's in high school, is 112 divided by 320. Let's just, and I don't think I've got really something like that in here, because I'll check if I can do something for you guys. 0.35, okay, 0.35. I'll check if I can do something, but it's very difficult to put this in Excel because one doesn't know what the question is going to be, so one doesn't know which fields to look at. But the important thing on this question for me is we are in that they give us, and they even highlighted it, that this is given. So when it's given, it is the conditional probability. And then the conditional probability formula is A given B is equal to the probability of A and B divided by the probability of B. Okay, so that is, so if you ever see the given in the exam, you know you're working with a conditional probability. And then you just follow nearly what you need to include in that conditional probability rules. Okay, and this could have been that they give you already, and let's just see if I've got one. Doesn't seem like it. Okay, no. So they could also, instead of the numbers, give you the probabilities as well. So let me just I'll check in one of the previous exams for probability table. Instead of where they give you the raw numbers, they give you the probability. So just a marker again for myself to add that to the next session. Okay. The other thing around probability that's critical, and you will get a question on that. So it will be in the exam, is about independent and mutually exclusive. So that definitely you can prepare that for the exam. You will get a question on that. So it could be that it is a question only on mutually exclusivity, could be a question only on independence, or it can be combined into one, like we have here. So this is, you will get a question on this. So please just make certain that you understand this. So let's run through some of these. The events AU, so Australia, and female are independent. Okay. First question, can we just from a table see if it's dependent or not, or must we work something out?
I'll have to calculate based on the definition.
Okay, so we need to calculate. So I'm like, let's skip that one for now. I want to see if there's something else that might be, and we're looking for the correct one. Okay, UK and female. Okay, so again, need to work something out. Events UK and female are mutually exclusive. UK and female mutually exclusive. Okay, so if it was mutually exclusive, the rule is that the AND will be equal to 0. So probability of UK and female for mutually exclusivity must be equal to 0. Okay, that is definitely not 0. So at least we have eliminated one of them. The events female and male are not mutually exclusive. Okay, so for this table, you are male or you are female. So there is not a non-binary option in this table. So you can only be male or you can only be female. So again, that is incorrect. It is the same if we ask, are you staying in UK, staying in New Zealand, or staying in Australia, UK, and New Zealand? You can't be in the same country at the same time. So they could have asked it the other way around to say, is the events Australia and New Zealand are not mutually exclusive. So that is wrong. And then if events UK and female are independent, UK and female are independent, then UK and female is equal to 0. That's also not right. That is when it is mutually exclusive. And we've done it actually there. It is not when something is independent. Okay, so unfortunately, for both of those two, we will need to work it out. So what's the probability? Is the probability of basically A times B. Um, so where is my, that's weird. I thought I did give it to you guys. Yes, I'm just looking at my page that I gave you guys, and it, okay. So it is hidden on there, but so probability of A and B, I'm just going to make it simple, must be probability of A times probability of B. Okay, so AU and female. So let's just clear this again. AU and female. Okay, so the probability of A is 102 over 580. The probability of B, which is female, is 260 over 580. So remember, we're looking at what's the probability that you are in Australia, and that's for everyone. So it's 102 divided by the 580. What's the probability that you are female? Is the 260 divided by 580. So that should then be equal to the probability of the two together, which is 52 divided by 580. So that, if that two is the same, then we know it is independent. Okay, so I'm just going to move this quickly to the other side that I can see numbers because somebody in the house have taken my my calculator. So 102 divided by 580 is 0.17, and there's some more decimals. The 260 divided by 580 give us 0.44, but there's more decimals. So if we multiply those two together, we get 0.07, and let's say 0.79. Okay, so that is if we work out this side. So we've worked out this side, and the answer is 0.079. So if we say 52 divided by 580, we get 0.089. Okay, so maybe I made a mistake, but maybe that is then also incorrect because the two are not the same. So let's then just check the next one. So events UK and female are independent. So unfortunately, it seems like I have picked the wrong one to work out first. In the exam, I would have gone and say, okay, that is not equal. And I would have said, then that is the correct answer. I wouldn't have even worked that out, but let's quickly check. So UK, that is too dark. So UK and again female. Okay, so let's see what's the changes here. So probability A and B is now 143 over 580. And we say that should be equal to, again, female stays the same with 260 over 580. But the extra one that comes in is now UK, which is 319 divided by 580. So let's see if that gives us different numbers. So 319 divided by 580 is 0.55. That one stays the same as 0.44. And that gives me 0.247. I multiply those two out. 143 divided by 580 gives us 0.247. Okay, so those two are equal, which means events UK and female are independent. Okay, this was a very long one. I was hoping that in one of those three, one could have eliminated and got the answers so that you don't need to work out the independence, because it does take time. But yeah, so at least we got the one that is correct. But again, that was my last try. So I would have still in the exam, I would have gone through these ones that is nearly definition, and I would have picked one of those that I know I need to calculate. And if I don't get the right one, I know the other one should be the right one. But this is, be prepared for the exam. You will get something like this. Okay, they will ask you in a question about mutually exclusivity and independence. It might be only one of them. It might be that both are in the same question. It might even be that it is two separate questions, but you will get something on this as part of the probability questions. Okay. There is a few more. So you'll see they give us exactly the same information in this one. So the same data set. Now they're asking us a few other questions. Okay, and you will see some of it was worked out here as well. But let's look at probability of male. Okay, so they said what's the probability of male is, and we did work it out, so it's 320 divided by 580, which does give us 0.55. Probability, okay, so now only UK is 319. Okay, so it's very close. So if you round it off, it will also give you 0.55. So that is correct. We're unfortunately looking for the incorrect one. So the probability of male, that was 320, of UK is very similar. So when you round it off, it will give you the same answer as 0.55. Okay, so let's look at probability of AU, so Australia and female. So Australia and female. So it will be the 52 divided by 580. And they say that is exactly the same as Australia and male. Ugh, the numbers are so close. So pure maths, I would have said it's incorrect. But so let's just, so the one is 52 divided by 580. The other one is 50 divided by 580. So let's just do this and we round it off to 2 decimals. So we round it off to 2 decimals, then it is exactly the same. So also let the number of decimals guide you, because if I was just looking at that, I would say, oh no, it's not correct. But if you go down to 2 decimals, it is the same. If you went to 3 decimals, it was not. So let the decimals please guide you in how you need to work it out, because theoretically, yes, voters are also not the same, but when you go down to the decimal level as they go, then it becomes a similar number. Yes, Lynn?
Thanks, John. Just quickly on the number of decimals, are there any rules we have to follow, or was it question based? Like these are giving
Yeah,
to,
I normally go with 4, but this is very difficult because you get instances. So with this you get 2, there you got 1. So it is, and you see later on there's there's 4. So what I do when I make calculations, I go to 4 decimals.
yeah.
If I need to multiply 2 decimals with one another, I normally take about 4 decimals, just to get maybe closer to,
Mm,
but 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 from how to use it, I'll, for me, look at the set of answers
mm,
and that
mm,
let that guide you.
yeah.
And that's unfortunate like that, because I'm used to 3 or 4 decimals, because if you look at your Z tables, I think that is 3 or 4 decimals. So I'm nearly always set in the mind of those tables how to look at things. Um, but I think what this is now a very good example of let the answer set nearly guide you in how many decimals you go to. Um, because from pure numbers, I would have just said, no, it's wrong.
Yeah.
Um, but but let the if, and that's interesting. Now that it's just sparked something else.
Mm,
If there wasn't that, and there
mm,
wasn't that,
mm,
if I just said
yeah.
that and that, then
It's a
it
bit
is wrong.
unfair.
Then it is wrong. So if there wasn't any numbers connected to it, then you can clearly see it's wrong. Um, but because they've given us rounded off numbers that are actually correct, it is correct. But if they actually excluded the numbers, then you can clearly see it is not the same. So and that is nearly let the answers set nearly guide you.
Mm, mm,
Um, the same year probably, they could have included numbers or something, but let the answers set guide you a bit
mm.
in what you need to calculate.
Thank you. Thanks, sir.
Okay, let's then look at probability of UK and M. So UK and M is UK and M is male. So again, that is, let's see, what is it? Let me do it on the other side, just. It is equal to 176 divided by 580, and that would have given us 0.3. So now you can see, now suddenly there's only 1 decimal. So again, but how to get it was 167, and remember, divided by the 580. They haven't told us, like in this instances, it is UK and male given male or anything like that. So they ask us UK and male, and when they don't give us that given, it is for the whole sample that we are looking at, which is for 550. So it's 176 divided by 550. So it's correct. Okay, so it is then one of these two. So let's first work out that one. Probability of UK given M. So we know now already that is the conditional one. So what's the probability of UK and M divided by the probability of M? UK and M, UK and M. Okay, we just did it. 176 divided by the probability of M, which is 320. And so while we have that, let's do the UK and female as well, because it's exactly the same. UK and female, 143, given female, 260. Okay, so exactly the same kind of what's a UK and female one is 143, but we divide by the probability of only the females, which is the 260. So one of them needs to be wrong. The 176 divided by 320. Let's look, we need to get to 2 decimals. So that is 0.55. 143 divided by 260. Also 0.55. That is okay. Yeah, that is fascinating. Okay, so that is the incorrect one. It should also be 0.55. That's quite. That's just weird, but okay, I'm not gonna complain now or say anything. But that is then the incorrect one because it should have been 0.55. Okay, so in this one, please let the decimals nearly guide you, else I would have had those first two as wrong as well. Because just by one or two numbers, it feels wrong. But if you then go down to decimal spaces, it is doable. Okay, so and we'll see now in the next one, let the decimals nearly guide you. Yes, Lynn.
That is not quick. I'll be quick, very quick. The previous one, I might have
Yes.
fallen into a little trap because why did we say for the probability in the last option 5, probability for female is 143 over 260, and not 260 over 580?
Okay.
Just
So
yeah,
it should have been, remember
yeah,
what it should have been, UK and female divided by,
yeah.
so UK and
Oh,
female is
okay.
143,
Right, okay, sorry, yeah. See that, yeah.
and it should have been divided by probability of female, which
Yeah,
is
okay, got
260.
it. Uh,
Okay.
oh yes,
So
oh yes, sorry. Okay.
that one we
Yeah.
just was the UK and female for the second one divided by the probability of a female.
Okay.
And
Okay.
I think that again it's important because sometimes when you see one of these, you want to nearly divide by one of those totals.
Mm.
And sometimes when you see you want to divide nearly the whole thing by the total. So what you nearly now said, the 260 divided by
Mm.
580, that would have been, what's the probability of being a female?
Yeah. Yeah.
Because that would have been
Yeah.
260 divided by 580.
Mm. Okay.
Then you would have gotten a probability of a female.
I normally use the 143 over the 580 and the 260 over 580, but it doesn't really matter because those values cancel out. Yeah.
Yeah.
Oh, okay. Thank you,
Okay,
John.
cool.
Sure.
Okay. Next one. Consider events A and B are mutually exclusive. Okay, so A and B are mutually exclusive. So if we know A and B mutually exclusive, we know that the probability of A, well, sorry, is 0. Okay, so remember the rules. If A and B is mutually exclusive, the probability of A and B is mutually is 0. Okay, so you will see a lot of mutually exclusive kind of questions because that is important. Okay, so I included just the OR rule. It is on your formulas sheet as well that I will still give you. But so probability of the OR that we need to calculate, because they ask us to work that out. So that's the probability of the A, 0.35, plus the probability of B, which is 0.65, minus the AND. They told us the AND is 0. So it's the probability of the one plus the other one, which gives us 1. Okay, so few things in here. You can't get a probability bigger than 1. Okay, so can't happen. So if you looked at it, option 3 is definitely not an option. I think if you probably multiplied that two out, you would have gotten option 4 as the answer. But for this one, straightforward, option 2 is the right one. But then you needed to remember that when something is mutually exclusive, the AND is 0. Okay, so this one, hopefully something like this is in the exam that you don't need to go through 5 or 6 options to get to your mutually exclusive and your AND. So remember, mutually exclusive, 0, then one can work it out. I hope the next one is then on independent. Yes. Okay, so exactly the same question that they're giving us. Consider now that events A and B are independent. Okay, so when A and B is independent, the probability of A times the probability of B will give you the probability of A and B. Okay, so the probability of A and B is equal to probability of A times probability of B. That is 0.35 times 0.65, which I get as 0.2925. See, now I go down to 4 decimals. So then let's do that. The probability of A is 0.35 plus the probability of B 0.65 minus the 0.2925. And why does it feel like I'm not going to get one of these answers? Okay, so 1 minus that. Okay, so let's see if I made a mistake somewhere. Because that is what I'm getting. I made a mistake in my calculation.
The product.
Where
That's 0.2275, I think.
yes, I've multiplied 0.45. So again, very easy to make mistakes. It should be 0.2275. So just please be very careful when you're doing calculations. How I got there is I said 0.45 times 0.65. So just a simple typing error and everything is wrong. So 0.7725 is your answer, which is option 5. So again, can't have bigger than 1. Here they actually given you the one that, so again, be careful when at that first step you see 0.2275 and you're like, there it is, and you just pick it. So remember what they're asking you to work out. They're asking you to work out the OR. So they want you to work out the whole thing. Okay, so here was basically 2 examples of the mutually exclusivity and the independence. So you can see I have included a lot of them because you will get something like this in the exam. So it's just on how they ask the question around it that might differ. But really important is this part. Okay. So maybe, okay. So now I've moved on from mutually exclusive, but there's still 1 or 2 that we've included. So this was from last year, from one of the students that sent this to me. So I've included the independence rule nearly for you. So let's look at which of the following statements is incorrect with regard to some relationships of probability. So I look at first at the easy one. So I look at where I can pick up mutually exclusivity. So if 2 events A and B are mutually exclusive, then the probability of A and B is equal to 0. Okay, so that is correct. We now known that now. If 2 events A and B are complementary, then A and B must be mutually exclusive. Okay, so that now is an interesting one. But if it's complementary, remember when we said probability of, so if we have probability of A is 0,5, the complementary of that is 1 minus 0.5. Okay, for this one that I picked, it was also 0,5. So the rule is that if A and B are complementary, and you can write it like that, or you can write it the C that is also seen as complementary. The rule is that if A and B are complementary, then the two events, the AND, will also be mutually exclusive. Okay, and you can go and test it. So you can go and test it out, but that is the rule. Because A and B is equal to 0, the not A and B will also be equal to 0. So that unfortunately have not helped. Okay, so let's look at, if two events A and B are complementary, then A and B is equal to 1. Okay, so that is what we just nearly, so that is correct. So if A and B are complementary, so basically what they say is that the complementary of A is equal to B. So if A is equal to 0.6, then the complementary of A is 0.4, which is equal to, because they tell us it's A and B, it's complementary. And so if you add those two together, you will get 1 again. So again, nearly the same principle that is with a mutually exclusive. This is a definition. It is a rule. If two events are complementary, if you add them together, you will always get 1. It is just so you can nearly take this as a given. So these, and if you want to make a note of this or use, I think this is a very good one for you guys to nearly have as a add-on to all your notes. Those 3 definitions that you can look at, or just add. You don't need to remember, study, or work it out. It is a given. Okay, so it is between those two. Okay, so if two events A and B are independent, then the probability of A given B is equal to the probability of B. Okay, so that's why I've included the independence rules. So, and how I always remember this is the probability of A given B is always the probability of the first one. So of the first letter. The same if it was probability B given A, it was the probability of B, first letter. And I think let's do an example. So let's say probability of A was equal to 0.3, probability was 0.4. Okay, so remember probability given B. So probability of A and B. So we now need to multiply those two out. Probability of A and B divided by, and let's get the right one, divided by probability of B. So remember the difference between the formula and what is the final answer. So probability A and B divided by probability of B. Those two will cancel out. So what are you left with? The first one, the probability of A. So that's nearly how I remember it is. And they can give you weird numbers. Z given U. Well, the answer is probability of Z. Okay, so just remember the easiest, how I remember it is if it's independence, the probability of A given B is the first letter. If it's swapped around, then it is again the first letter, which is B. So that one was the incorrect one, but let's look at this as well. So probability of A and B was equal to 0.4, and probability of B is equal to 0.5. If A and B are independent, then probability of A is 0.8. Okay, so they are now, I'm going to take this out. It will be on the recording in any case. So they're doing it now a bit from the other side. Okay, so let's still, so if A and B are, so probability A and B, we know 0.4. So what is the probability of B? 0.5. So the probability of A is that question that we need to answer. So they've done it nearly the other way around. So 0.4 divided by 0.5 is 0.8. Okay, so it's good that we just checked that one as well. So working nearly basically from the other way around, we know the probability, what the formula is, but we don't know what the answer is, but they're giving you those two sets of answers. So it's nearly like reinverting the answer and working backwards. Okay, we're so used to work out the normal flow of a formula. So this was quite an interesting one, how they actually went now the opposite side. Okay, so there is definitely in some of the later ones on normal distribution, there's one or two like these types of things as well. Okay. So here we have, yes, Lynn.
What is that? On the quick, the previous one, Is
Yes,
there one more rule for independence? The one where I think we spoke about the product. So probability of A and B is equal to the probability of A times probability of B. Is there also one more rule for independence? You know?
yes. So,
Okay.
so,
Okay.
and that is why if you look at this is nearly the short, the short right of that, because your rule is just like you said. So you will have, let's say that is that you work out your probability. The rule is normally probability of that A and B divided by the probability of B. So that is this is your normal rule.
Mm.
If you now talking about your conditional rule, but when it is independent, then you nearly can go straight into that as a short form for your conditional probability,
Okay, I see. Okay.
because like I showed, you would have had something like this, or it would have been rather that, and those will fall away so that you only sit with the probability of A.
Yeah.
So you can nearly, this was your conditional rule that we did here in the previous ones a lot. But then if you know that it is independent, you can move from this straight to that.
Okay.
So if you know it's
Cool.
independent, you don't need to work out that. You can just say, but my answer is when the probability of A.
All right.
Okay, so
Cool.
you can then nearly bypass all the other calculations and just go straight to the answer.
Sure. Thank you.
And that is also, Lynn, I think what is important. So if I gave you this question and they ask you, work out probability of A given B. They told you it's independent, they give you that, then you could have, the short form would have been very easy because they give it to you.
Yep.
And what might happen is in the exam you forget about that link and you go and work out that whole answer, and you will in the end
We'll
still get
get.
to it, but it will be 3 minutes or 4 minutes later.
Mm, mm.
So and I think that is another thing. Just sometimes, and I think that's a human thing. Nearly we always, and unfortunately stats have made us think that way. Is we nearly, in that sense of they always want to catch us out, or it's difficult or something like that. But sometimes there is a very straightforward, simple question, and we look at it and it's like, okay, but it can't be just this. There must be a catch. So I think that for me is something that when and there will be I think a prep exam as well. I will just ask the lecturer. There's normally in that last week or two, there is a prep exam. So we will work through that as well, where you will get an a paper that that you can test your timings and those kind of things. So I'll just check in with him again on that, so that one can nearly, I think the thing that you guys need to practice now more is the timing with the exam, so that you can see if there is catches and if there's shorter ways of doing things.
It should be a mock online exam, John.
Say again?
Would it be like a mock online exam? So like
It will
putting
be a mock online exam. Yes. Yes.
okay.
Okay, cool. So we've got a few minutes still, so let's look at this one. Okay, they give us a table. They say complete the number missing before calculating, but I first look at things that might be, so the event woman and type A personality, okay, we're looking for correct one, is mutually exclusive. Woman type A, it if it was mutually exclusive, that would have been a 0. It isn't a 0, there's 19 people. It's incorrect. So I'm not even filling in numbers yet. I'm just checking first. Okay, let's look at, there's an answer. Maybe we can look at that. Probability of women and type B. Okay, so we've got a value there. So 11 divided by 150 must give us that answer. So 11 divided by 150, 0.073. Okay. That's correct, actually. Okay. So in the exam, I would not have now gone further and checked it. If I am then wrong, then it is my mistake then in the exam. But that is, so yes, they tell you that, but I would have looked for things, but I don't need to do that yet. Okay, but we've got 7 minutes, so let's finish this one off and let's just, okay, so now let's look at all the the givens. So probability, male and type B. So probability of male and type B is 42, given that it is type B. Okay, so we don't know that. So let's add those two together. It's 53. So 42 divided by 53 is not going to give us that. That is for sure. 42 divided by 53 is 0.79, which is actually that one. Okay, so what will probably happen is that if we work out this answer, it will give us 0.35. So let's look at the other way around. Probability, again, of the ant is 42. Even men, 120. So 42 divided by 120, yes, is equal to 0.35. Okay, so also wrong, but interesting how they just swapped it around. So again, for you guys, this is nearly testing if you know which ones to divide with, because very easily one could have now made the mistake, and then you could have actually said both of them is correct. And the last one, probability of women. Okay, so we need to know what that number is. So that is 30, and it is divided by everyone, which is 150. So 30 divided by 150 is 0.2, okay, which is also incorrect. Okay, so this was one that I would have, in the exam, I would have gone to the things that I didn't need to fill in. It's just how I always look for the easiest kind of ways to get to things before I need to start calculating. So yeah, so option 3 was here the correct option. Okay, so I'm gonna stop now because the electricity is going off at 10, so I just want to make sure that the recordings and everything is safe, that I can put it on the chat. Okay, so let me just stop this, that I know it's all fine.